side function is polynomial function. Like, let me show you first. Yeah, this function we have considered earlier. So not only x to the power m, I mean, if you consider x to the power m, it means you are considering the general term from a polynomial function. So it actually, if you understand this method, you can consider any kind of polynomial. And also we have discussed a very interesting function which is exponential function. So these two functions we have considered in last class. So today we will consider a different function which often occurs for real problem, like sine function or cosine function. I mean, see, we have very few rules, okay, for which we can use simple trick to find the particular integral. But for most of the problem, we need to go through
So
the
what is
classical
PI?
technique. Is it your first class? Is it your first class? PI is particular
No, sir.
integral. If it is not first class, then you should know PI means particular integral. Okay, so the general solution of any second order non-homogeneous equation can be written as sum of complementary function plus particular integral. So at the very first class, we have discussed the techniques how to find the complementary function, and last class I have started how to find the particular integrals. Okay, so we have discussed two different type of functions in last class. So now we'll consider the right hand side function, let's say, is given as sine ax or cosine ax. Okay, these two functions we will first consider, and then we'll consider definitely we have to consider some more functions. Let us see what happens with sine ax. Okay, so particular integral, as I have discussed in last class, that it is nothing but 1 by fd of sine ax. Remember, this portion 1 by fd, it is an operator, and this is the function sine ax. Okay, so you have to basically operate 1 by fd on sine ax. Now let's say very simple function, if you consider 1 by d, that is 1 by fd is, let's say, 1 by d, and if you operate that on sine ax, it will give you back just integration of sine ax. Okay, but the problem is, if it is 1 by fd is not 1 by d or 1 by d square. If it is 1 by d square, then double integration. If 1 by dq, then triple integration. So these are very simple cases, but it can be any polynomial. Fd can be any polynomial in d, that we have discussed last day. So that can be of this form, like d to the power n plus p1 d to the power n minus 1 plus so on pn, where we have considered earlier that p1, p2, so on pn, these are the coefficients and which we have considered for the timing as constant. Certainly they can be constant, they can be any function of x, but for the timing we have considered these are any constants. Okay, so now see how to find this particular integral, or in short pi. So let us see these steps, follow these steps. That is, let's say you operate d on sine ax. D is the differential operator with respect to x. So you can easily find d of sine ax is a cos ax. Likewise, d square sine ax is minus a square cos minus a square sine ax. Okay, and likewise, if you find d square to the power n, okay, that means d square d to the power 4, d to the power 6, and so on, you can easily say that value will be nothing but minus a square to the power n into sine ax. Okay, you can check it. I mean, find d to the power 4 of sine ax. Okay, that will be simply a to the power 4 sine ax. So that means minus a the square sine ax. Okay, so it is for n equals to 2. Similarly, you can find for any n. Okay, so you can say, see here, you can simply say now, let's say you have phi d square. Phi is any function of d square. Okay, instead of function of d. So see, we have started with a case that is, it is fd, 1 by fd, but we cannot generalize it for any function. Rather, if it is function of d square, then only we can use this method, because we can have a relation here that we have just now derived. It's very simple relation, by the way. That is d square to the power n sine ax, you will get back minus a square to the power n sine ax. Okay, so we'll use this property. We'll use this property to find the particular integral. Now let's say phi d square is given, which is the rational function of d square, any function of d square. Okay, so then if you operate this phi d square on a sine ax, okay, then what it will be? It will be simply phi of minus a square sine ax. You can verify it. You can verify it from this relation. Okay, so so it will be simply nothing but your phi of minus a square sine ax. So if it is true, then from this you can set some formula. See here, you can write, of course, you have to consider phi of minus a square. Minus a square is non-zero. Then only you can set some formula. So if it is non-zero, then you can divide phi of 1 by phi of a minus a square here. So it will be minus 1 by phi of minus a square sin x. Then it will be 1 by phi of b square sin x. Okay, so as if 1 by phi of minus d square is the function. Phi of d square is the function that you are considering on y, and you have the function actually x sin x. Okay, this is what the differential equation now. Okay, we have started with the general case, but it's not possible to find the general case except this particular situation. That is, the differential equation is given in this form: phi of d square y is equals to sin x. In that case, the particular integral turn out to be 1 by phi of d square sin x, and its answer is 1 by phi of minus a square sin x, provided phi of minus a square is non-zero. So you may have a doubt that what about this case? Yeah, we have to discuss that. But let us first illustrate the particular situation where phi of minus a square is non-zero. Okay. So the formula is now, this is what the formula, okay, that we have discussed. And likewise, so here remember the differential equation is now phi of d square y is equals to sin x. Okay, this is what the differential equation. So the particular integral is this 1 by phi of d square sin x. That value is 1 by phi of minus a square sin x. Okay, provided phi of minus a square is non-zero. So instead of sin x, let's say you have given the equation as phi of d square y is equals to cos ax. Okay, so likewise you can find the particular integral in this form. It's quite straightforward, similar to the previous case also only. Okay, so it will be similar 1 by phi of minus a square cos ax. Okay, okay. Remember, double derivative of sin x is same function. I mean sin x, again some factor is there, and likewise cosine function, double derivative is again cosine function with some factor. That's why you can implement that formula only for sine and cosine. But for sec function, let's say sec ax is given, we cannot use this formula. And of course, we cannot use this formula even for sin x and cosine x if phi of minus a square is 0. So we have to consider them separately. I mean, we cannot use this simple formula there when the denominator 1 by phi of minus a square is 0. Okay. So let us consider an example. And as I have mentioned in last class that we have already discussed how to find the complementary function. So we'll skip we'll skip the discussion on finding CF here. You please work on that. It's very simple. Because see here, for this case, I mean this differential equation, the auxiliary equation will be m cube plus m square minus m minus 1 is equals to 0. So you can simply find the roots, and you can say roots of this equation to find the complementary function. So this is your, of course, a homework. You please try to find this one. I think you can easily do. Now let us see how to find the particular integral. Okay. So see here, you have the differential equation is dq plus d square minus d minus 1, that you are, I mean, you can write it in operator form like dq plus d square minus d minus 1 y is equals to cos of 2x. Okay, cos of 2x. So this is what the differential equation. So particular integral will be what? 1 by fd. Fd is dq plus d square minus d minus 1. Okay.
Sir, hello.
Yes.
Sir, minus 2 whole square means 4 minus 1 whole square. It will be 9, sir. You have written 25.
Acha, I will go there. Let me discuss it. There may be some mistake. Let me discuss it.
Okay, sir. Okay, sir.
Okay.
No, sir.
Because
Correct.
Say, I mean, if in this way 500 students ask me this is wrong, this is correct, it will be really tough for me to complete the course. Okay. There might be some mistake. I am also human being. If there is mistake, definitely I will rectify that one, and definitely I will say sorry. So first listen me, okay, beta.
Okay, sir. Okay, sir.
Okay. So what you do here is the pi is 1 by fd cosine of 2x. Okay. So now see, you can factorize it. This factorization is known to you. All you can do that. So it will be 1 by d plus 1 d square minus 1 cosine of 2x. Okay. Now see, as we know, we can apply this formula if the function is given as a function of d square. If it is given as a function of d square, then only we can apply this. So let us try to write this term as a function of d square. Okay, but here it is d plus 1. Okay, now see, it is actually 1 by fd. Now see that you are operating on cosine of 2x. So what we will do now, we will multiply here d minus 1 in the numerator and the denominator also d minus 1. So this operator remains same. There is no change in the operator. So we can do it. Okay. So now if we do that, d minus 1, if we multiply with the numerator, so numerator will be d minus 1 and denominator turn out to be d square minus 1, and here also d square minus 1. So it turn out to be d square minus 1 third square. Okay, so now see here it is d minus 1 by d square minus 1 the square cos 2x. Okay, so you can break this part in this way, like you have d minus 1 into 1 by d square minus 1 cosine of 2x. Okay, so this is what this third bracket, first we will find the value and then we will go for this term d minus 1. Okay, so the third bracket term is 1 by d square minus 1 the square cos 2x. So as we have mentioned that d square should be replaced by minus a square. Okay, so a is 2, so it will be minus 2 third square minus 1 third square. Sorry, this minus 2 third square minus 1 the whole square cos 2x. So it is 4
So
minus
how
1
A
third
is
square.
minus 2?
Yeah, a is 2.
It is given in the question.
Let
Cos
me, you
x.
are right. It will be, sorry, there is a mistake again. 1 by, let me correct it. Okay, 1 by, it will be minus
3
2 third
minus
square.
Sir, 2 square, yes sir.
Yeah, minus 1 third square.
Because A is 2.
Yeah, a is
Yes,
2. Yeah, so it will be minus of 2 third square. Okay, so see here it is 1 by minus 5 third square cos 2x. So it will be 25. So mistake was there, but this was the mistake, that it will be minus a square. It will be minus a square minus of 2 square. Okay, so answer is correct, but there is little mistake. There was little mistake. So this is what the correct form. Okay, now see, we have d minus 1 remaining term. So you have to operate that on cosine 2x again. So d minus 1, that if you operate on cosine, so first is d of cos 2x, that is derivative of cos 2x minus cos 2x. So derivative of cos 2x is minus 2 sin 2x minus cos x, and denominator turn out to be minus 5 the square, so 25. So this is what the particular integral. So answer is complementary function plus particular integral. So you please complete the derivation of complementary function and then write the solution as a sum of complementary function and particular integral. Okay, so now see here it is for cosine x. So one homework you can consider here, replace it by sine 2x. Replace it by sine 2x. Solve this problem. Replace it by sine 2x. Okay, replace the right hand side function by sine 2x and solve it. Okay, so this is again another homework. You please try. I hope you can solve it. Now here I have considered a different function instead of sine function and cosine function. Let's say you have sec function, sec of nx. Okay, so we cannot use the technique that we have discussed for sine x and cosine x, because that can be used if, I mean, this formula can be used if the right hand side function sine x and cosine x. And the interesting fact is there that double derivative of sine function and cosine function is again the same function with some multiplier, but it is not true for sec function, sec nx, let's say. So how to find the particular integral? First part you please try on your own. You can do it. How to find the complementary function, I will discuss here only the particular integral. So particular integral from formula, you can say it is 1 by d square plus n square sec nx. Okay, this is what the function. Now let me tell you another thing. One of your friend wrote me an email earlier that, I mean, he or she might be present today, that if this kind of function is given, sec or whatever, he wanted to multiply in the numerator x and the denominator x with x. Okay, now see, if you do so, then what he wanted to do is he wanted to consider this function. This is completely wrong. See, you cannot do in this way, that 1 by d square plus n square, then operate that on the denominator function only, not the numerator. It is wrong. You have to treat the function as a whole, a single function, and then treat this operator on that particular function, not individually with the numerator or not individually with the denominator. Okay, it is completely wrong. Don't do this. Okay, because see, this is what the operator and this is what the function. So you can operate this operator as a whole on the function, not only with the numerator or denominator, because see, the denominator there is always 1. So if you just implement this d square plus n square on the denominator, it turn out to be 0. This is meaningless. Okay, you cannot do that. Okay, so the operator should be, you have to implement, you have to operate this whole operator on the whole function given here, that is sec nx. Okay, so now see, we don't have any simple formula here for sec function. So what we have to do, we have to somehow form some first order differential equation out of this, then only you can solve it. And in last class we have discussed that one, so let me highlight that again. Okay, so now see, 1 by d square plus n square. So d square plus n square can be can be written as a product of two first order differential operator like d plus ni into d minus ni, and then you have to do some algebraic calculation. So that's what we have done here. So if we write this d square plus n square in this way, see, the one factor is d plus ni, another factor is d minus ni. So if we write it in this way, like 1 by d minus ni minus 1 by d plus ni, so in the numerator you will have an extra term, that is 2in. So that's why I have divided this term by 1 by 2in. So it makes sense that we can write this term in this way, 1 by d square plus n square. And then the function you have to write, this is what the operator now that you have to operate on as a whole on sec nx. So see here, we have now to the first order differential equation. See, if we write, I will come to this point later, let us see this note. That is, let's say we are considering 1 by ni, 1 by d minus ni, and that you are operating on sec nx. You can do that, it is linear in nature, so you can do that. And another one will be 1 by d plus ni, that you have to operate on sec nx. Let's say that is z. So one function is y, another function we are considering z. So the answer turn out to be 1 by 2in into the first one will be y minus z. So if we can find y and z, we are done with the finding the particular integral. So we have to now work on this, how to find this capital Y and capital Z. So I have shown here how to find Y. So 1 by d minus ni, that you are operating on sec nx, you are getting back y. So you can form out of it a first order differential equation. And similar discussion we made in last class. So it will be d minus I and y, okay, is equals to sec nx. So remember, d is ddx, first order derivative. So this is nothing but first order linear differential equation. First order linear differential equation. So for this kind of problem, the complementary function is e to the power minus p dx. Sorry, e to the power p dx. So e to the power, yeah, p dx. So you know that p is what? Minus in. So it will be p is minus in. So p dx will be minus inx. So there is nothing wrong in finding the integrating factor. And answer will be what? Y into integrating factor is equals to integrating factor into the right hand side function, right? That you have to integrate with respect to x. So that's how we can find y. So you just multiply now e to the power inx in the both sides, then you can find y in this way. Like then z will be what? Z for this, the differential equation turn out to be d plus in z is equals to sec nx. So replace n as it, replace n by minus n. Okay, here it was minus, here it is plus. Okay, so replace n by minus n, that's it. So one particular integral is this one, another term is this. So this is what y, this is what z. So now this, the remaining part is simple integration. Simple integration. I hope you can do that, even though I have shown that in next slide, you can see here. So see here, you can write inx, e to the power inx or minus inx in terms of cosine and sine function. That is the exponential formula for complex number. E to the power inx is cos nx plus I sin nx. Likewise, e to the power minus inx is cos nx minus I sin nx. So you just replace this e to the power I sin nx plus and minus by using the complex form. That is cos nx plus I sin nx and sin nx, cos nx minus I sin nx. and then integrate it. This integration is 12 standard integration. I guess you can do. However, I have shown the derivation here. However, I have shown the derivation here, and see the pi turn out to be free from complex number. Of course, it should be free from complex number if you do the calculation. So I must say you please check it. It is correct, but you please check it. So do the calculation on your own, because this is nothing but
Yeah,
simple
yeah.
integration. You can do that.
Yes, sir. Correct, sir.
Yes, yes. Correct, na? Great. So
Yes, sir.
two more homework I have given, sec square x and 10nx. Okay. You please try to solve this. Not only this 10nx, you may consider here cot nx, right hand side function, or cosec nx. So these are all your homework. Here also you can change this function by cosec square x or sine square x. Okay. So these are all your homework. Consider the left hand side as it is, change the right hand side function to form a different equation. Okay, so these are all your homework. You please work on it. I hope you can do this. If you follow the if you follow the method, you can do that. And another problem here, see, one different case I have considered, phi of d square y, that is given here, sine 2x. Okay, now here see phi of d square is d square plus 4. So phi of minus 2 square is 0, because it will be minus 2 third square plus 4. So minus 4 plus 4, so 0. So actually here we have phi of, see, earlier formula what we have written for this kind of situation, 1 by phi of minus a square. Okay, but phi of a square is 0. Phi of minus a square is 0. So that case we have to now discuss with this problem. Okay. I mean, for this case, we cannot use the technique that we have discussed previously, because that was strictly applicable for the situation where phi of minus a square is non-zero. But here it is 0. Okay. So,
Okay, sir.
okay. So see here, I will just follow the previous technique that we have discussed. That is only the classical technique, and it is applicable for all problem. But for this classical technique, you may have to do more number of steps to get the solution. But frankly speaking, this technique, classical technique, is applicable for most of the problem where the differential equation has constant coefficient. But you cannot use it for the cases where the differential equation possesses some variable coefficient. That is only the restriction here. Now see, and it will be really painful, this classical technique, if the order of the differential equation is higher, because in that case you should have more factors. See here, it is second order differential equation, you can expect 2 factor will be there. So it is quite straightforward. But if it is 5 degree or 10 degree differential equation, it will be really mess. I mean, you have to do lots of calculation using this classical technique. That is the drawback
Yes.
here. Okay. So now see, we can break it in this way. See, 1 by d plus 2y into d minus 2y, we can write in this form, in this way. You can simply arrange this term in this way, right? You can do that. Earlier also we have done the similar job. So here again we will consider see here, from this we can say that 1 by, let's say 1 by d minus 2y sine x we are considering as y, and another will be considered as 1 plus 2y sine 2x as z. Okay, so the answer will be 1 by 4y into y minus z. So if our task is now to find y and z, and finding y and z is nothing but you have to form some first order differential equation which are linear in nature, so you can easily solve it. So it will be 1 by d minus 2y sine x, sine 2x is y. So you just form the first order differential equation. So you can say it is first order linear differential equation. So use the technique, that is integrating factor will be your e to the power integration p dx. So here p is 2 minus 2y, so it is what? Integrating factor. And answer is y into integrating factor is equals to integrating factor into right hand side function dx. Right hand
Yes,
side
sir.
function is 2x, yeah, sine 2x. Okay, so y can be easily evaluated here. You can easily integrate it, because e to the power I2x or plus I2x or minus I2x, you can expand them using the complex form, that is cos 2x plus I sine 2x or cos 2x minus I sine 2x accordingly. So you can solve it. See, I have not completed the derivation. You please complete the derivation. First find y, then find here z. Once you can find
Okay,
y
sir.
and z, yeah, you can do that, right?
Yes, sir.
Okay, great. And similarly, you work on this problem also. This is what your homework. Only the right hand side function that was considered as sine 2x, here I have considered as cosine 2x. Another few homework I am giving here. Consider the left hand side as d square plus 4y is equals to, let's say, cos square 2x is given, or cos 2x sine 2x is given, or let's say tan 2x is given. Okay, sec 2x tan 2x is given. Okay, left hand side is same. Okay, so you please work on these problems. Now we will consider a different type of function. Let's say you have given the differential equation as f dy is equals to function of x, where this function of x is e to the power x into some another function of x, where a is constant. So e to the power x into v, where v is any other function of x, where v is any other function of x. Okay, so I mean, earlier we have considered e to the power x only. That means we have considered as if v is 1. Now we are generalizing that. Let's say you might have some function like e to the power x into sine x, or you might have some another function e to the power x into sec x, or cosine x, or e to the power x into some polynomial. Okay, the product of two functions. One of them is e to the power x, another one is any function of x. Okay, let us see how to establish the formula. Formula is derived here, but I will just highlight some of the steps, because derivation is not that much complicated. It's very simple if you know the derivative only. Okay, and some algebraic calculation. Let me illustrate. So if you operate d on it, the right hand side function, differential operator d. Can I write this in this way, e to the power x v? If you differentiate it, can I write this in this way, e to the power x d plus a into v? Yes, we can do, because see, d of e to the power x, d of e to the power x into v, if you use the uv formula, so it will be e to the power x d of v plus
V into
a,
into
yeah, e to the power
a.
x v,
Yes, sir.
right?
Yes,
So
sir.
that is
Yes, sir.
arranged. I have arranged in this way. See, it will be e to the power x into d plus a that you are operating on v, right?
Yes, sir.
Okay. So you please check it. Just find d square that you have to operate on e to the power x on v. So d of it first first order derivative we know. So you can write it as d of e to the power x d plus a on v. Okay. Now again use as if this is two function. This is what u, this is what v. Then you can write it in this way. Okay. Right? It is quite straightforward, because d square, if you operate that on e to the power x v, that means d 2 times you are operating. One time you already know, that is e to the power x into d plus a that you are operating on v. So as if it is product of two functions. One is e to the power x, another one is d plus a that you are operating on v. So as if it is product of two functions. So again it is product rule you have to use. Then check it. Do you have anything that I have to, I mean, do you have any query that I have to derive this, or you can do it or not? Tell me just. Then I will proceed.
Yes,
So
sir.
what
It
is
is okay.
V1?
Yes.
Huh? What
What
is?
is V1?
अच्छा मुश्किल तुम लोगों को लिए. I will
First
come to
derivative.
V1. I will come to V1 and all. But tell me, do you have any query here?
No, sir.
Okay. देखो बेटा, सामने जो है हम डिस्कस करेंगे ना, जो पूछ रहे हैं उसका थोड़ा बहुत आंसर दो, वही काफी है मेरे लिए. ठीक है. I think you can do it, right? So likewise, you please check it for any n. All you can do is use method of induction.
Yes, sir.
Okay. So now see, So that means what? If you have dn, you are operating on e to the power x on v in d to the power n, you are operating on e to the power x v. You are getting e to the power x, and d is shifted to d plus a to the power n, and that you have to operate only on v. So that means it is now free from the derivative operator. You have another term here, only this term. Okay, but d is not d here. It is just d plus a. So if you say any function fd, okay, the general form that you are operating on e to the power axv, then what will be the answer? It will be just as if e to the power x, you take it out from the operator, and because of that d is shifted to d plus a. But this is not free from derivative operator. Okay, now we'll proceed how to find v1 and integrating factor. Okay, so if this relation is correct, then operate 1 by fd on both the sides. So this turn out to be 1 then unit operator, because if you have inverse operator with the given operator, that turn out to be the identity operator. Identity means 1. So it will be just simply this function e to the power xv. And right hand side turn out to be 1 by fd e to the power x into this function f of d plus av. F of d plus av. Okay, now we are considering two different functions here. Let's say, see, f of d plus a v. This is another function of x, right? Because v is function of x. F of d plus a is a function of some operator, differential operator. So that differential operator, if you operate on function of x, it turn out to be again a new function of x. That can be constant, that can be 0. But you can simply say it is a function of x, because constant and 0 all are function of x, we can treat that. So generally, this will be a function of x only. Function of x. So that function we are considering as v1. Okay. So if it is, we are considering, then you can write v in terms of v1. You can easily say that v will be 1 by f of d plus a, that you have to operate on v1. So just substitute 2 into 1 to get the answer. You will get that answer now. So the answer is, see, this is nothing but algebraic calculation. You can do it easily. So answer is now, see, I mean e to the power x, and then you are substituting v by this function. So 1 by f of d plus a v1, and the right hand side function is 1 by fd. Okay, and e to the power x, f of d plus a v, that is v1. So it turned out to be e to the power x v1. Okay. So we have started with this term, right? 1 by fd to the power x v1. So that if you, that means what? 1 by fd, you are operating on a new function, that is e to the power x into v1. Okay. You are getting the answer as e to the power x 1 by f of d plus 1 v1. So see, e to the power x is now free from any differential operator. Only this term involves the derivative operator or integration operator, because it depends on the form of the function. So you can take e to the power x out of the operator. So this is what the formula. So in general, I mean, instead of v1, you can write v. I mean, here we are not writing it as replacing v by v1. It should be, I mean, instead of v1, we are writing again in terms of v. That's it.
Why,
Okay.
sir?
अच्छा, अगर ये नहीं लिखेंगे तो क्या प्रॉब्लम है? कुछ प्रॉब्लम है? v1 is any function?
No, sir.
No, sir.
This is any arbitrarily chosen function. नामकरण इसलिए किया गया है ना, क्योंकि v1 से बेटर है v. इसका कोई जरूरत भी नहीं है. अगर नहीं चाहिए तो छोड़ दो, ठीक है? You can end here. But v1 is arbitrarily chosen function. Better you write 1 by fd to the power x. v1 के जगह में कोई भी फंक्शन ले लो, u ले लो, क्या प्रॉब्लम है? कुछ नहीं. Okay. So this is what the formula. Okay. So let us implement it. Then it will be more clear. Okay, because the theory is okay, but let us implement it with some very simple example that I have considered here. E to the power 3x x square. So you have v here x square, and e to the power 3x is given. fd is d square plus 2. You please complete the derivation on CF that I must skip here. I will only consider particular integral right here. But in order to get the solution, you have to find CF, and at the end, you please write the solution as sum of CF and PI. That you have to do. So let us see how to find PI here. So here it is 1 by FD e to the power AX into V. Here A is 3. So see, as per formula, what it was? 1 by FD e to the power AX V1. So you can take e to the power AX out, but D here shifted to D plus A.
D plus 3.
Yeah, D
whole
plus
square
3.
2.
So it involves your operator, but this is free from operator. That is the beauty of this technique. Now, what you can do is you can stop here and find separately 1 by D plus 3V. Then again you substitute that value right here. So now target is to find this term only. There is nothing to do with e to the power 3x. This is just a multiplier. Okay. Now see, d f of d is d square plus 2. So f of d plus 3, you can find it as d plus 3 the square plus 2. Expand it. It will be, you can simply write d square plus 60 plus 9 plus 2, so 11. And we have already discussed how to find the particular integral when the function is x to the power m. So this part we have already.
Sir, how
Isn't
FD plus 3 is coming like this?
Are you following my lecture?
Yes,
D
sir.
to D plus A. Yeah, no.
If you are, frankly speaking, you are not following. I have discussed this one already.
What's the value of FD A plus A?
What is FD?
FD the function D square plus 2.
What is FD here? FD means you
Yes,
have
sir.
the
Yes, sir. Yes,
difference.
sir. Oh, yes, sir. I didn't see that. Sorry, sir.
What you are doing. Okay, you must be little careful. Okay, beta. ठीक है, कोई बात नहीं. Okay, so we have discussed already this term, that how to find 1 by this function, 1 by d square plus 60 plus 11, that you have to operate on x square. Can you solve it or not? Tell me.
Yes, sir.
I am just showing you the formula. Okay. So that you can, yeah. So here we have discussed this earlier. The idea here is you have to expand FD to the negative power of D and arrange that in terms of ascending power of D. Just binomial series expansion actually you have to use. Let me highlight again, discuss a little bit. You may forget. It will be good then. So see here, we have 1 by d square plus 6d plus 11. So what you have to do is, if this kind of term is there, 1 by d square plus 60 plus 11 x square, take some common here and try to write the denominator as 1 plus some function. So if you take common 11, so it will be 1 plus d square plus 60 by 11 to the power minus 1, right? Then expand it. Then expand it in binomial.
Can we take d square common and then expand?
Can you take d square common? Acha, tell me, are you really following my lectures or not? In
Yes,
last
sir.
class,
Yes, sir.
okay,
Least degree common, sir.
Yes, sir.
ये प्रॉब्लम समझ में आया था जो लास्ट क्लास में हम डिस्कस किए थे. Why we
Yes.
have common the minimum degree here? Common. Why you have taken minimum degree D here? Why not DQ? Why not D square?
Sir, then it will be difficult for us.
It
So
will be
because then the
difficult
differential
for us.
operator between the denominator. So in denominator it is difficult.
Yes. So better you consider the least power. Okay. जब
Okay.
3 टर्म रहेगा, so you are free to say, sir, why not dq, why not d square? So better you consider least power of d. Then see here, the beauty here, if you consider least power, after 2 terms, all the terms turn out to be 0 because x square is given. But if you could take common 1 by dq, so dq, that you have to 3 times integrate.
Yes, sir.
And it will be really very, very complicated. So remember here, for this problem, take common, the least power of d. Okay, that can be d to the power 0 or d to the power 1, whatever, the least power among these. Okay, so that's why I have considered here least power as a common. Okay, so 11 is taken as this, it is d to the power 0, so that's why. Then expand it in binomial series. Now see, you have x square, so there is no point to write the term of order d square plus 60 to the power cube. There is no need. Now see, d square plus 60 by first term is d square plus 60 by 11, that you have to operate on x square. Second term is d square plus 60 the square by 121, that you have to operate on x square. Okay, so calculations are done here. You please check it. It's very simple because this square derivative here you have to basically find derivative, first order, second order, whatever. So if you expand it, it will be d to the power 4 plus 12 d cube plus 36 d square. Now see, dq and d to the power 4, if you operate that on x square, it will be 0. Only you will have only one term, that is 36, that into d square x square. Okay, so second order derivative, so that will be 2 actually. And here it is first term d square minus 6 plus 60. So here you have, for both the terms you have non-zero value. D square x square is 2, 6dx square is 12x. So we can find individually this term, and first term is only x square into 1. So I have calculated, I have completed the derivation here. See, these are the things that we have done, and first term is x square. Substitute these two value here to get the answer. So you please check it. It's very simple, by the way. And few more problems are given here. Even the answers are also given PIs. Okay, you please check it. See, this function is e to the power x into cosine x. Here it is x e to the power 2, it is x into e to the power x. Another function is also given 2 into e to the power minus 4x sine 2x. So what you do is, for this kind of problems, let's say you have f d y is equals to some e to the power x into v plus e to the power bx into u. Okay, where u and v are any function of x, they have no relation, may have relation, may not have. So what you do is particular integral, term wise you find. First see the contribution from this term. So let's say that is pi1, even you can write it as 1 by fd e to the power ax v, another pi for the second term. This suffix denotes the contribution from the first term, and another one is for the second term. It will be 1 by fd e to the power ax v, u, not v. Here it is.
So bxu.
Yeah, bx. Yeah, you are right. So it will be e to the power bxu. So answer will be, I mean, the particular integral will be pi1 plus pi2. So question is, why we can write it is sum of these two? Because it is linear differential equation. Okay, it cannot be considered, we cannot write the answer as sum of these two if it is not linear. If it is non-linear, we cannot do that. But we are considering now linear. Even in your course, you have only the linear differential equation in maths too. Okay, later on we have non-linear also, that will be discussed in the next semester maybe. So now the another formula that we have to discuss, that is, if you have x into v, okay, instead of earlier function we have considered e to the power x into v, now we are considering x into v, any function x. Okay. So I have directly written here the rule. You please check it whether this rule works well or not. Okay, so rule is, see here the problem is same, 1 by fd, you have to operate that on xv. It will give you back this formula that x minus f dash d by fd, again 1 by fdv. X minus f dash d by fd, 1 by fdv, where f dash d, treat this as just function of d, just find f dash d. What will be f dash d then? For this example, let's see. Fd is d square plus 4. Here it is d square plus 4. So f dash d will be as if you are differentiating again it with respect to d. So it will be 2d. Okay. It is actually function of some difference, some differential operator that you are differentiating with respect to d itself. Here f dash d means derivative of fd with respect to d, not with respect to x. Okay, with respect to d. So see this example, x into v. So here you can have FD and F dash D is 2D. So the PI will be X minus F dash D. F dash D is 2D by FD. By FD is D square plus 4. Again 1 by FD sine 2x. So now we have to complete the derivation. See here, this is one operator as if 1 by D square plus 4 that you have to operate on sine 2x. That you have to operate on sine 2x. So this problem, the solution I have written here directly. So you have to check it. We have solved this problem actually earlier. Let me show you that where we have solved. Yeah, this problem actually. D square plus 4y sine 2x. Yeah. So this problem we have solved. You find this answer first. That answer is minus x by 4 cos 2x. Now you have to operate this operator on this function. So what will be the answer then? That I have done the calculation here. Up to this, I have shown here in this particular slide. Now let's see from this step. Okay. So see here, you have x minus 2d by x d square plus 4, and this answer is 1 by d square plus 4 sine 2x is minus x by 4 cos 2x. You please check.
Yes,
Okay. Okay.
Yes, sir.
So now I will proceed with this. So see here, x into this term. So it will be minus x square plus x square by 4 cos 2x. Fine. Next term is quite difficult because here it involves some differential operator. So the operator is d by d square plus 4 that you have to operate on cos 2x. And sine is minus, minus plus, and 2 and 4. So half. Up to this is okay then. So now we have to find d by d square plus 4 that you have to operate on x cos 2x. That you have to operate on x cos 2x. Okay. Now what about d of x cos 2x? This is the differential operator, right? This is the derivative operator. So you can easily find d of x cos 2x. That is what? This one? Cos 2x minus 2x? Yes. So
Yes,
then
sir.
it turned out to be 1 by d square plus 4 into this term. Cos 2x minus 2x sine 2x. Now see, this problem we have already solved. 1 by d square plus 4 cos 2x we have already solved. And another term, that is 1 by d square plus 4 x sine 2x. 1 by d square plus 4, it will be plus
2 by d square by 4. 2x. So 2 by d square by 4 x sine 2x.
Yeah, that term okay. Cos 2x is fine. But what about this term?
It is the
PI,
PI
sir.
itself.
PI.
It's itself the pi. Yes. So it will be minus of pi. So 2 pi you have now. Left side we have started with pi, right? And right hand side we have minus pi. So 2 pi is the rest term. Right? So you can simply divide it by 2 to get the pi. It's very interesting problem. See here, most of the formulas we have to use here. So you please work on this problem again. Go through the derivation. I think you can solve it then. And again, you consider another problem here. D square plus 4y is equals to x cos 2x instead of sine 2x. Instead of sine 2x. Consider x cos 2x.
Sir, we have another class, sir.
Oh, sorry. Time is over, right?
Sir, so the previous slide.
Huh?
Previous slide, sir.
Yeah. So. You have, I am sorry, time is already over. Anyway, if you have any query now, you may ask me.
Where will you upload recording?
In MS Team, I will upload the recording.
Sir,
Sir.
And sir,
there
please
is
upload
2x
notes also.
sine 2x. Sir, how 2 is going?
Sorry?
Oh no, sir. There is half. No, sir. Understood.
Okay. एक बार देख लो है क्लास के बाद क्लियर हो जाएगा if you have any
Sir,
doubt
please
in-
upload notes also.
With the
अरे
annotation.
यार सब कुछ कर देंगे don't worry. बाकी कुछ बताओ if you have any query related to this discussion.
Yes, sir. ऊपर सर ऊपर. सर.
सर आप नीट पे
अटेंडेंस कैसे लेते हैं?
अटेंडेंस जो तुम लोग ज्वाइन करते हो ना, अटेंडेंस ऑटोमेटिकली मेरे पास आ जाता है।